Hello everyone, good morning. This is Mr. DHAKSHUNHAAMOORTHY, AP-AIML department. Today's topic is policy gradient method. In Unit 5, Deep Reinforcement Learning, Introduction. The goal of any reinforcement learning RL algorithm is to determine the optimal policy that has a maximum reward. The policy gradient method or policy iterative method, that means modeling the optimizing the policy directly. Policy gradient algorithm. Policy gradient algorithm is a policy iteration approach where policy is directly manipulated to reach the optimal policy that maximizes the expected return. This type of algorithm is model free reinforcement learning RL. The model free indicates that there is no prior knowledge of the model of the environment. The environment dynamics or transition probability is indicated as below. Probability of st plus 1 given that s comma a, where it can be read the probability of reaching the next state st plus 1 by taking the action from current state. Policy phi is a distribution over actions given states. In other words, the policy defines the behavior of the agent. Pi of a given that s. Return and reward. A return is defined as the sum of rewards from the current state to the goal state. Example, sum of rewards in a trajectory R of t is equal to summation t is equal to 0 to capital T minus 1, where reward of st comma at, where t equal to s naught a naught comma s1 a1 dot 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 st minus 1 and at minus 1. Objective function. In policy gradient, the policy is usually modeled with a parameterized function respect to theta comma pi theta of a given that s. We consider a stochastic parameterized policy pi theta and aim to maximize the expected return using the objective function j of phi theta. J of phi theta equal to e expectation of pi theta summation t is equal to 0 over t minus 1 r of st comma at, that is expectation of phi theta r of total t. Objective function j pi theta is evaluated by summing of all the rewards, that is why expectation of r total. The best policy will always maximize the return. The gradient ascent is the optimization algorithm that iteratively searches for optimal parameters that maximize the objective function. If we can find out the gradient of the objective function j as shown below, gradient of j pi theta equal to gradient of expectation of phi theta of r total. The gradient update rule is as shown below. Theta equal to theta plus alpha into gradient of expectation of pi theta r total, that we can rewrite theta equal to theta plus alpha into gradient of j theta with respect to objective function j theta. Derivation of the policy gradient expression. The expectation of discrete random variable x can be defined as expectation of x is equal to summation of I xi p of xi, where x is the value of the random variable x and p of x is the probability of function of x. Now we can rewrite our gradient as below. Gradient of objective function j of theta equal to gradient of expectation of pi theta r total equal to gradient theta summation over t probability of t given the theta and r total. Gradient of expectation of r total equal to gradient theta summation over t p of t given the theta into rt. Bring the gradient under summation. Now the gradient is moved inside the summation symbol. Next, what we are doing, we are multiplying and dividing by p of t slash theta. Then the modification is happening in the previous step. In the next step, we are taking log derivative trick based on the gradient theta log z equal to gradient theta z by z. Similarly, the form here p theta p of t given the theta divided by p of t given the theta with gradient of p of t given the theta divided by p of t given the theta is looks like gradient of z, gradient theta z by z. So we are rewriting that expectation of gradient theta logarithm of p of t slash theta into rt. Return to expectation form. P of t given that theta equal to p of s naught into product of t equal to 0 or t minus 1 probability of st plus 1 given that st at pi theta of at st, where p of s naught is the probability distribution of the starting state and p of st plus 1 given that st at is the transition probability of reaching the new state st plus 1 by performing the action from the state st. If we take the log probability of the trajectory, then it can be derived as below. Log p probability of theta given the theta equal to t given the theta equal to log probability of s naught plus summation t is equal to 0 or t minus 1 log p of st plus 1 given that st at plus log phi naught pi theta of at comma st. We can take the gradient of the log probability of the trajectory, thus gives pi theta log probability of theta t slash theta equal to gradient of log p of s naught plus summation t is equal to 0 to t minus 1 gradient theta log p of st plus 1 given that st at plus gradient theta log pi theta of the gradient of the log probability of the trajectory we can modify this function as shown below based on the transition probability model. Probability of st plus 1 given that st comma at disappears because we are considering the model free gradient algorithm where the transition probability model is not necessary. Gradient theta log probability of t given the theta, where we are removing the initial state and the transition state values because this one is model free gradient algorithm. Then the gradient theta log phi theta of at comma st, that we can rewrite summation t is equal to 0 or t minus 1 phi theta log phi theta, the gradient theta log pi theta of at comma st. Final derivation of the gradient of log probability of the trajectory, we can now go back to the expectation of our algorithm and the time to replace the gradient of log probability of trajectory with the derived equation above. Gradient j theta equal to gradient of expectation phi theta of rt. Gradient theta summation over t probability of t given the theta rt, that is equal to expectation of pi theta of gradient theta log p probability of t given the theta and rt. Now the policy gradient expression is derived as expectation pi theta of gradient theta log probability of t given the theta into rt, that is equal to, we are replacing here the probability of t given the theta, that those values at this place. So expectations of phi theta summation t is equal to 0 or t minus 1 gradient theta log pi theta of at comma st into rt. The left hand side of the equation can be replaced as below. The gradient j of theta, that is objective function, gradient of objective function is approximately 1 by n summation t is the element of capital N, and another summation t is equal to 0 to capital T minus 1. There are two summations. Once the inner summation we completed with the t is equal to 0 to t minus 1, then we have to do the overall outer summation where t is the element of capital N. Here inner summation gradient theta log pi theta of at comma st into rt, where n is the number of trajectories is for one gradient update. Thank you.